Good morning, class. Miss Anderson here. Today we're talking about midpoints and segment bisectors. By the end, I hope that you can identify a midpoint and use the segment bisector definition to solve for part or whole segment lengths. So a couple first definitions. If you have congruent segments, those are line segments that have the same lengths. So there's the diagram example. Got this mark right here shows that they are congruent. So we want to have that mark. We never want to assume that two segments look to be the same. We want to make sure that we see this mark here that shows that they are congruent. And then congruent means equal, and so your symbol for congruent is very similar. You would say that segment AB is equal to segment CD, but the only difference between the equal and then the congruent is you put a little squiggle above the equal. So that symbol is our symbol for congruent, which in geometry means that they have the same length. Now, if you have a segment and you have a midpoint of the segment, which means a point in the middle, then it divides the segment into two congruent segments. So if M is the midpoint, so if you have segment AB and M is in the middle, then that means that this part and this part are congruent. Or more formally, that AM is congruent to MB. Notice that we use that congruent symbol there. And that means that the length of AM is equal to the length of MB. So if the segments are congruent, then their lengths are equal. So remember, these are segments notation with the line above it, and this represents just the length of those segments without the line above it. Similarly, a segment bisector is a line or a line segment that intersects at its midpoint, also creating two congruent segments. So we have midpoint M, so segment AM and MB are congruent, and this line CD, is bisecting segment AB. And we can say the same thing then. These two segments are congruent. Here is that statement. And then their lengths are equal. So this is their length are equal. And this means that they are congruent. So let's use those definitions to help us solve a few problems here in lengths. Okay, so if point Q is the midpoint of PR, find the length of PR. So this is referring to a length. And if Q is the midpoint, that means that this segment is congruent to this segment from PQ to QR, which means that you can set their lengths equal to each other, or PQ is equal to RQ, and then that's what it is mathematically. 9y minus 2 is equal to 14 plus 5y. So notice that we have y variables on both sides, and in order to isolate that variable, we have to have all the variables on one side. So we will start by moving the y's to the other side. On the right, I have a positive 5y. The inverse of that would be minus 5y. So I'm going to do that on both sides. Line it up with the like terms, which means with the other y term. 9 minus 5 is 4y. And then minus 2, we're going to bring that down because we haven't changed that. 5y minus 5y is 0. So on this side, we just have 14 left over. And then we got to get the y by itself. So we're going to get rid of the minus 2 by adding 2 to both sides. Get 4y equals, this will be 0 here, so 14 plus 2 is 16. And then 4y means 4 times y, so we'll have to divide to get 1y, and 16 divided by 4 equals 4. So y equals 4, and remember you're looking for the length. So now you're going to have to substitute back in the 4 in order to solve for each of the lengths and then find the total length by using segment addition postulate that we learned last time. So remember we want to find, oops, I drew my P backwards. PQ plus QR will equal the length of PR. So if we plug in 4, you're going to have 9 times 4 minus 2 be 36 minus 2, which will be 34. So PQ is the length of 34. This would be 14 plus 5 times 4, which will be 14 plus 20, which is 34 again. And we know that they were equal, so that makes sense. And then adding them together, you'll get 68 for a total length for PR. Okay, and this one, B is the midpoint of AC, which means that AB is congruent to BC. So there's my congruent marks. I'll make those more straight. These are congruent. Since I know that they're congruent and I know that AB equals x plus 6, that means that this side also equals x plus 6. And you could do that two ways then. You could do at segment addition postulate then. So AB plus BC is going to be equal to AC. And so we're going to add those together. So x plus 6 plus x plus 6 is going to equal to 3x minus 31. And then we can combine our like terms. And you could have started this one out as 2 groups of x plus 6 as well, and then distributed the 2 because you have 2 of them. Or combine like terms, 2x, 6 plus 6 is 12, remember, because that's a 1 and a 1x, and then that equals 3x minus 31. Now we need to get our x's on one side. We have more x's on the right, so I'm going to subtract 2x from both sides just so that I end up with a positive coefficient for x, but you don't have to do it that way. You can go the other way if you want. Bring down the 12. 3x minus 2x is 1x. Bring down the negative 31. Add 31 to both sides. And we get 43. And 1x is x. So you get x equals 43. And if x equals 43, 43 plus 6 is 49. So our question was finding the length of BC, so the length of BC will be 49 units. This is a very similar example. Since we have the identify the segment bisector of PQ, then find MQ. So since we have that these segments here have these markings, that means that PM is congruent. We can say segment PM is congruent to segment MQ because of these markings here, the red ones. So in that's the case, then the length of PM is equal to the length of MQ, which means that line L is the segment bisector. And we can take the length of PM, 5x minus 3, and set it equal to the length of MQ, which is 11 minus 2x. And then we can solve for x. Hopefully I left myself enough room here. Actually, I'm going to make that a little smaller. So there we go. So I'm going to solve here now. I need to get the x's by itself. I have more x's on the left, so I'm going to move the negative 2x by adding it to both sides. I'm zoomed out too far. 5x plus 2x is 7x. Bring down the minus 3. And I got an 11 left over here, and this is 0. Then get the x by itself, so add 3 We got 7x equals 14. Divide by 7, you get x equals 2. And then it was asking you to find the distance of MQ. So the length of MQ is equal to 11 minus 2x. Substituting in that 2, be 11 minus 4, which is 7. So MQ is equal to 7 units. Okay, a couple more. Given that AB bisects CD, determine CD. So we're really getting our algebra skills, useful algebra skills here. So if AB bisects CD, that means that the length of C to the midpoint here is congruent to that point to here. So these lengths are congruent, or this is congruent to this, or equal. Their segments are congruent, that means their lengths are equal. So we can set this equal. So 2 times 3x plus 5 is equal to 4 times x plus 6. So in this problem, we have a number in front of a parenthesis. So we need to do the distributive property first, which means the 2 multiplies into both. 2 times 3x is 6x, and 2 times 5 is 10. 4 times x is 4x. 4 times 6 is 24. Now isolate your x's, so move all your x's to one side. I'm going to move them to the left because there's more. Positive 4x, so minus 4x. Line up the like terms. And then over here we have 24 left, then minus 10 on both sides. And we get 2x equals 14. Divide by 2, and we get x equals 7. And the question was asking us to determine the length of the whole segment. So we know that the segments are congruent, so we can plug in the 7 just to one side, and then we'll know the length is equal on the other side. So I think it looks easier to plug it in over here. 4 times 7 plus 6 would be 4 times 13. To multiply 13 by 4, we can double it, so 26, and then double it again, which would be 26 and 26 would be 52. Yep, 52. So this segment's 52. That means that this also has to be 52, and 52 plus 52 would be 104 units for the whole length of CD. All right, one more. Okay, so AB and CD bisect each other, and CD is 16 units. Determine the value of x. Okay, so since they bisect each other, that means that this distance from here to here is congruent to this distance from here to here, and then this distance is congruent to this distance here. So notice I use 2 marks to tell the difference. It doesn't mean that this distance is congruent to this distance. It just means that they bisect each other. So this one is congruent to this one. So those distances are equal. And then these distances are equal. So notice that this one has a y in it and this one has an x. So I'm not able to set these two equal because they have different variables. However, I do know that the total length of this one is 16, and I know that these are congruent. That means that I know that this piece is also 3y minus 1, and that together the total distance is 16. So all together this distance is 16. So I could solve for y by doing 3y minus 1 plus 3y minus 1 is equal to 16. And adding the like terms gives you 6y. Negative 1 plus negative 1 is negative 2. Be careful with that. And then we're adding 2 to isolate our variable. You get 6y equals 18. Divide by 6. We get y equals 3. I have to move that up so it stays on my page when I print this to PDF. Okay. So y equals 3. So now if we take y equals 3 and we do 6 times 3 plus 1, that would be 18 plus 1, which give you a length of 19, which means that this is also 19 because remember these two segments were congruent as well. And our goal was to find x. So now that we know that 4x minus 29 is equal to 19, we can solve that for x. So setting them equal, then using inverse operations. So adding 29 to both sides. 9 plus 9 is 18. Carry the 1, 2, 3, 4. And then 4x left on this side. Then divide by 4. If I'm dividing by 4, I'm going to cut this in half, which is going to be 24. And then I'm going to cut that in half again, which is going to be 12. So x is equal to 12. Okay, so in summary, if you have a segment AB and you have a midpoint M, that means that these are congruent. So segment AM is congruent to segment MB. And if they are congruent, so you see this symbol or you see the marks here, that means that their lengths are equal. And we can use that to solve a lot of properties in lengths in geometry. Thanks for watching. Whoops.